2017 number 4, the famous potato problem. We are looking at a baked potato, or actually it's a boiled potato, sorry, taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees at time t equals 0. It's 91 degrees Celsius. And the internal temperature of the potato is greater than 27 degrees for all times t greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that will satisfy the differential equation dh dt equals negative 1/4 h minus 27, where h of t is measured in degrees Celsius and h of 0 is 91. We're going to write an equation for the line tangent to the graph of h at t equals 0. Use this equation to approximate the internal temperature of the potato at time t equals 3. So, as always, with a tangent line, we need a point and a slope. The point's given as 0, 91. The slope, h prime of 0, we will get from dh dt. And when the time is 0, h is 91, so we plug a 91 in for h. A lot of people struggle just right here knowing what to plug in here. H prime of 0 is when t is 0, but the dh dt, the variable is h, so we have to plug 91 in for h when t is 0. So it's negative 1/4 91 minus 27. You get negative 16 for the slope. And so now we have our point and slope. So the tangent line is y minus 91 equals negative 16 times t minus 0. And you can leave it like that, except for, since we have to estimate the value of h at t equals 3 using the tangent line, I'm going to go ahead and solve for y. And you get negative 16t plus 91. And then y of 3 at time t equals 3. The tangent line will have a value of 43, so we will estimate that the potato's temperature is 43 degrees Celsius at time t equal 3 minutes. So now for part A, there are 3 points possible. 1 point for your slope, 1 point for your tangent line in either form, and 1 point for the approximation at time t equals 3, which is 43 degrees. Part B, we're going to use a second derivative of h with respect to t to determine whether or not your answer in part A is an underestimate or an overestimate of the internal temperature of the potato at time t equals 3. So the second derivative, in order to take that second derivative, I went and took the first derivative, I multiplied it out, and makes it really easy to take this derivative then. The derivative of negative 1/4 h plus 27, I need to point out we're taking the derivative of h with respect to t, but my variable is h. So we're going to have a chain rule, and it's going to be negative 1/4 dh dt. So the second derivative is negative 1/4 dh dt. And that means negative 1/4 dh dt, I substitute back in what they told us dh dt was, negative 1/4 h minus 27, which gives you positive 1/16 h minus 27. And since they told us that h is greater than 27 always when t is greater than 0, that makes this second derivative always positive. And if it's positive, it's going to be concave up. So we should know that when a function is concave up, a tangent line will always have an underestimate. So the tangent line estimate is an underestimate because the second derivative is greater